Hello everybody, and welcome to today's Advanced Combine session. My name is Donnie Walls. I am the author of a book called Practical Combine. If you want to learn more about Combine, my book will teach you everything you need to get started with Combine, and it will show you exactly how Combine could fit into your own projects. Now, if you buy the book today, you will get a 25% discount with discount code WWDC 2020. This code is valid until June 30th, so you still have a couple days left. In today's session, I would like to take a look at a couple of non-trivial and relatively complex data flows that you can implement in Combine, and we're only going to use Combine's operators and subjects to implement them. First, I will show you how you can build a data source object that supports infinite scrolling in a table or collection view, and the second example that I want to show you will explain how you can implement a token refresh flow that is very common in OAuth or other token-based authentication implementations. And of course, after refreshing the token, we'll automatically retry the request. Let's get started. Tons of apps that we use today feature lists that scroll forever and ever. Think Twitter, Facebook, Instagram, they all load more and more content as you scroll down their feeds. Now, implementing a list that scrolls infinitely usually involves creating some kind of an object like a view model or a network object that you can ask for more data when needed, and you can often provide a completion closure that will be called whenever this data is loaded. Alternatively, you could set up some kind of a delegate relationship, or you can even fire a notification through Notification Center if that is your jam. Now, with Combine, we can use a subject to send newly acquired data to subscribers without having to resubscribe every time we request new data. Let's take a look at some code. Okay, so what we're looking at here is a very simple data fetcher class. It has a current page property and a load next page function. The current page property will keep track of what page we should load next and where we currently are with loading pages. The load next page function can be called by users of the data fetcher to tell it to fetch new pages. As you'll see, it doesn't have a completion handler and it also doesn't return anything. Because as I mentioned before, we're going to use a subject to relay new pages to subscribers. So I'll start by defining a pass-through subject. Let page subject equals pass-through subject. And this subject will emit data and it will never emit any errors. So that's step one. And I know we're going to need it later, so I'm going to define a cancellables set. Okay, those are the properties that we're going to need. Let's add some code to load next page. Since we're going to load URLs in load next page, I have to build the URL that I want to load. And for now, I'm going to use a placeholder URL that will just point to my website. In reality, of course, this would point to your paginated API. And to load the URL, we're going to use a URL session.shared.dataTaskPublisher for and then the URL that we want to fetch. And since we need to grab the output of this request, we're going to have to subscribe to it using sync. Now, the task can fail and it would emit an error in the completion, but we don't really care about that. So I'm just going to pass the completion closure as empty. I am interested in receiving the value. So I'm going to say result in, and then I want to relay the result of my network call to the page subject. So I'm going to say page subject.send result.data. Now this will send the data off to the page subject. And since we are subscribing to a URL session data task, we will have to store the cancelable that's created by sync in our cancellables array. So I'm going to say store in cancellables. Now we can see if this works by using the fetcher and calling load next page on it. I've already created an instance of data fetcher that we can use. First, I will say fetcher.pageSubject.sync, and then the receive value closure will get data. So for now, I will just print this data. And I will also have to store my cancelable. And nothing would happen if we run the code now because we haven't told it to load next page. So let's do that. I'll tell it to load next page twice. Now if we run this playground, you'll see that we get 2 print statements. If I add another load next page, we'll get another print statement. This works perfectly, and it looks good, right? Well, I tend to disagree. I'm not a huge fan of having to subscribe in our load next page. I would much rather make the data task and not subscribe to anything at all. Just forward the data task directly to the page subject. Let's see how we can do this. Now, in order to not have to subscribe to a URL session data task inside of the load next page function that I just showed you, we're going to have to use a flatMap and an extra subject. A flatMap in Combine takes a value that's emitted by a publisher and allows you to transform this value into another publisher. The output from every publisher that is created in flatMap is then sent to a single subscriber. Now, for example, consider a publisher that emits URL objects. You can flatMap these URL objects into data tasks, and the results of these data tasks are all sent to the same subscriber. When you're doing functional programming, you often think of things in states of, or in streams of. When you're doing functional reactive programming, you often think in terms of streams of events or values. And almost everything that happens in your app is the result of something else that happens somewhere else in your application. And all of these things happening can be thought of as a stream of events. For example, a user tapping a button is an event, or a user scrolling and eventually triggering a new page load, or even the user locking their device, entering a location, turning on the camera, turning off the camera. Anything they do could be considered an event. And typically your application will not do much until these events happen, right? Your application will often sit idly until the user does something to interact with it, or until the system does something that will trigger something in your app. Now, all these events, all these things that make your application do something can be thought of as values that are emitted by a publisher. And as you know, values that are emitted by a publisher can be flatmapped into another publisher. So this means that you can take all kinds of user interactions and requests and turn them into publishers. And subscribers can then subscribe to this flatmap publisher that emits all these events generated by these flatmap publishers, and you can use this to model some really cool features. Now, do you see where I'm going with this? It's okay if you don't, because I'll show you in a moment. Okay, so as I just explained, we can think of anything that happens in our application as part of a big stream of objects. So every time the user taps something, scrolls something, locks their device, or anything, we can think of it as the user adding an event to a big stream of events. And when we model the world like this, we can do interesting things. So let's see how that works by creating a new pass-through subject for our load next page requests. We're going to say let page request equals pass-through subject that will emit void. Because even though I want to emit something, I don't really want to emit a value. I just want to use this as a mechanism that can sort of, signal that something happened. I'm going to copy this URL because we'll need it later. I'm going to clear out load next page. And in load next page, all we really want to do now is say page request.send void, just so that any subscribers of page request will be notified when something happens. The next step right now is to take page subject and change it into something else. So I'm going to make it a lazy var because the initialization for page subject depends on the page request. I'm also going to get rid of my cancellables array here because I don't need it anymore. The page subject will no longer be a pass-through subject. Instead, it will be an any publisher. So I'm going to say page subject any publisher that will emit data just like before and never fails just like before as well. And I'm going to use a closure to initialize this property. Well, the first thing I'm going to do is take page request, which will emit void values, and flat map over it. And by flat mapping over it, I can transform these void values into publishers. And the publisher that I want to create will be a URL session data task. So I'm going to paste the URL that I copied earlier and say return URL session dot shared dot data task publisher for URL. And since I know the Swift compiler will be unhappy with this, I am going to give it a little hint and tell it that we return a URL session data task publisher here. Now, since we want to have never as our failure type on this any publisher, we need to catch any errors that might occur in the flatMap and replace them with something. Now, for this, we can use a nifty little publisher called empty. An empty publisher does not emit any values, and it immediately completes. So this means that whenever our network call would fail, this empty will sort of just make it do nothing, which is fantastic and makes never our error type. The next step and the final step here is to map over the results. And the result here will be an object that is the result of the URL session data task. And we're going to extract data from it because we want to return data, not the full URL session response. And we're going to erase this all to any publisher. And this is all that we really need to do to change the code that we had before. Let's see if it still works by running it. And as you can see, we have 3 print statements. Now to show you that it really still works, let's add a 4th print statement. Voila, we have 4 prints in the log. So what we did here is we removed the need to subscribe to anything by flat mapping over an existing publisher. Page subject is no longer a publisher that directly emits its values. Instead, we took page request and we created a new publisher based on page request by flat mapping over page request's emitted values, creating a URL session data task, removing any errors, extracting data, and erasing to any publisher. This is much cleaner, and I'm way happier with this because we no longer have to subscribe to anything inside of a data fetcher. Let's go back and see what else we can do with Combine. So now that you know that you can think of things happening as streams of events, and you know how to represent this with a pass-through subject, you can take this entire idea a step further. In OAuth-based applications, your application can obtain a token from a server. Now this token is then sent along with every network request to the server that if the endpoint requires authentication, and this token is always valid for just a limited amount of time before it needs to be refreshed. Now it's possible to, of course, proactively refresh tokens before you make a request to prevent them from even expiring before you make a network call, but every once in a while you'll encounter an expired token anyway. In an imperative style, you might have a method that makes a network call and checks for token errors in a completion handler. Now, if a token error occurs, you would call this another method to refresh the token, which would also take a completion handler, and then inside of that completion handler, you would call the initial network call again, and then keep that going until you have a valid token. Now, that's a bunch of completion handlers and a bunch of nesting going on, and everything is very tightly coupled together. And to be honest with you, I kind of get dizzy just thinking about it. Luckily, we can use Combine to make this process a lot easier. If you consider obtaining the currently available token as a stream that might emit more than one token, you could combine flatMap and current value subject to trigger a token refresh that will automatically retry a network request without all kinds of crazy closures and all callbacks being stacked on top of each other. Sounds good? It does to me. Let's take a look at some code. All right. I've already defined a couple of objects to give us something to work with. I started with a token. This token can be valid or invalid, and it doesn't have any further properties because we don't need them. In reality, tokens are of course far more involved and they would have a couple more properties, but we don't need them for now. I also created an authenticator class. Now this authenticator will give us a current token that we can use to make requests, and we can obtain that token whenever needed. I also wrote a refresh token function, and this function takes a subject and we simply send a new valid token over that subject immediately. In a real application, this would of course make a network call to your service, and it would do the whole token refresh dance as needed. But for now, we don't need that. We're just going to assume that that code might be there, and it will always succeed, and it will do exactly what we want to whenever we want it to do something. We're going to write our code in the user API here. And the user API will try to make a request, and if that request fails because a token is invalid, then we will refresh the token and we will make the request again. So that's what we'll do, and let's see how we can do this. The first thing to do in this getProfile function is to create a subject, and this subject will be used to drive the getProfile request. And we're going to base it off of our token. So I'm going to say let token subject equals current value subject that emits a token and has never as its failure type. And the initial value will be authenticator.currentToken. Now I'm going to use the token subject to kick off network requests, so I'm going to flatMap over it. And this will also be the publisher that we return, so I'm going to say return token subject dot flatMap, and that is going to take a token. And I will also go ahead and erase this to any publisher, so I don't have to do that later. Now that I have a flatMap that receives a token, I would normally construct a URL that has this token in its header and sends it to a server. Now I don't have an OAuth server ready, so instead I'm going to determine whether I should construct a valid URL or a URL that will result in a 404 based on the token's validity. So if the token is not valid, I will create a URL that will give me a 404 response so that I can filter on that to determine if the token needs to be refreshed. In your own applications, that would probably be a 403 response or any other response that your server uses to tell you about expired tokens. Okay, so now that I have a URL, I can go ahead and return URL session .shared.dataTask publisher for my URL. And this dataTask publisher can emit a value, and I want to determine based on that value what I should do. So if I get a successful response, or at least a response that is not a URL error, I'm going to flatMap over that, get the result, and I can now inspect this result to see if the HTTP status code was 404, and if it is, I want to kick off a token refresh and retry my request. So I'm going to go ahead and say if let HTTP response equals result.response as HTTP URL response, and if the HTTP as response.status code equals 404. Now if this is the case, what I want to do is kick off a token refresh. So I would tell self.authenticator.refresh token using token subject. So this will send the token subject over to the authenticator so that the authenticator can refresh or create a new token and submit that to the token subject. Now this will kick off a new value in the token subject, which will trigger my flatMap again and allow me to retry the request. Now, because I don't want to send this value out to any subscribers that would receive this if I wouldn't do anything here, I am going to replace the publisher here with an empty publisher. So I'm going to say return empty dot erase to any publisher. And if everything went well and we didn't get a 404, I can say return just, and then take the result, extract its data, set failure type, because we need to have a failure type, to URL error.self, and also erase that to any publisher. I'm also going to set a return type here to help the Swift compiler, Let's say URL session.data task publisher. And lastly, I am going to erase this to any publisher too, and give the compiler one more hint about what we return. And also update the other flatMap that I have in here. Okay, so we should be able to compile the code now. Okay, the code compiles. Let's see how this works and if everything works as expected. So I can say api.getProfile.sync. I don't really care about the completion right now. I only want to get the value data and print data. So what I expect to happen here is that I would eventually get data, which I don't because I have not stored my cancellables. So let's say store in cancellables here and retry. And sure enough, once the playground finish, I will see my data appear. There we go, my data appeared. Now let's see if we actually refresh the token or if we just got lucky. So here I will print needs refresh, and here I will print all good. Let's run the playground one more time. And sure enough, once the playground finishes, we will see needs refresh, all good, and then the bytes printed. There we go. So this is a fairly complicated structure to implement, but it's also built on very simple rules. We take a token subject, and every time it emits a value, we flatMap over this. We make a request to a server, and if this server responds with a 404, we want to replace that publisher with something else. So we're going to flatMap over the data task publisher, inspect the response, and then return an empty publisher if we got a 404. We also tell the token authenticator to refresh the token and send a new value over the token subject. This will kick off the flatMap again and make a new URL request. If we did not get a 404 response, we extract the data from the URL session data task result, and we create a publisher that will simply emit that data immediately. We have to erase any publisher a bunch of times to make sure that flatMap has a readable return type. But ultimately, we have a pretty simple API that's really powerful because it automatically refreshes requests or retries requests every time we get an invalid token response. This is really cool, and even though it's complicated, like I said, it is built on very clear and simple rules. Now, in the example that I just showed you, you were able to build a really complicated flow using building blocks that are familiar, but they're used in a complicated way. I cannot stress this enough, that the building blocks are simple. They're always the same. It's the application that makes it complex, and the application that makes it powerful. And in my opinion, that's part of what I love about Combine. Learning the individual building blocks is relatively simple, but once you learn the complicated and more complex patterns, you'll see how much you can do with Combine simply by stacking the building blocks in cool new ways. So in this session, I showed you that subjects and flatMap can be used in cases where you want to respond to something, which could be anything that happens in your application, like requesting a new page or refreshing a token, to drive something else, like loading a new page or attempting to access a resource on the network. If you liked this session or want to learn more about Combine and how you can use it, make sure to check out my book, Practical Combine. It's available on practicalcombine.com, and you can grab it with 25% off until June 30th using discount code WWDC 2020. Thanks for watching.